Okay, guys, we're going to try something a little bit different to get this to work, and I'm hoping that I'll be able to draw a little bit better than I have been with some of the other podcasts that I've been doing. So, bear with me. Anyway, this is part two of the podcast about graphing sinusoids, and we're going to be working on this handout. This is it says graphing general sinusoids at the top here, and we are gonna, going through this, the first part here just really talks about the things that we just went over in part one, the names of these things. The one thing I want to point out in here that we didn't discuss here is this idea, right, um, that the period is 360 divided by b. So 360 degrees is the natural period of sine or cosine, right? So this idea of that's how long it takes to complete a cycle of sine or cosine normally is 360 degrees. And if my dilation factor is 1 over b, right, 1 over b times 360 degrees is going to give me excuse me, the number of degrees it takes to complete a cycle in my dilated view, right? So 1 over b times 360 degrees, it's the same thing as 360 over b, right? And this is the new period. Remember, the period is the time or the number of degrees it takes to complete one full cycle. So this is just the outline. We're going to go ahead and we're going to look at this problem down here at the bottom. As we go through it, this should clarify some of the issues that come up. And it has step-by-step directions. So the first thing we're going to do, one, graph this function here. We have negative 8 plus 10 sine 5 times negative theta plus 6. Remember that there are secret parentheses here, right? The entire argument of sine is 5 times theta plus 6. Okay, step one, draw the sinusoidal axis at y equals c. So the question, where do you want to draw that? Well, I'm going to draw that, right, I want that to be in the middle of my graph. Now, the problem is I got to put some axes, scales on my axes. I want to draw my vertical axes so this whole graph fits on. What I want to do is kind of think ahead, right, about where the sinusoidal axis is going to be and where my maximum value is going to be and my minimum value is going to be. Now, remember that the amplitude is telling me how far I go up or down from my sinusoidal axis. So in this case, negative 8 is the sinusoidal axis like I have here. And if I go up 10 from the sinusoidal axis, I get a max of y equals 2. And if I go down 10 from my sinusoidal axis, I get y equals negative 18. Okay, so that's going to allow me to make a good choice about how I'm going to scale my axes here. I'm going to go ahead and I'm going to go ahead and draw on, maybe too much here, a vertical axis. I'm just going to arbitrarily decide to draw it right about here, okay? And I want the top of my graph to be about at 2, and my bottom of my graph hopefully is going to go down to negative 18. It looks like a scale of maybe like 1 per scale or per square is going to work out great. So I'm just going to go ahead. I'm not going to label every single one, just so that we can save ourselves some time. I also am going to actually make you watch me write all this out because you should be writing all this out as we do this, right? So follow along with me as this goes, as this happens. Don't just, be bored watching me write numbers. Fill out your graph. If you need to pause it, pause it. Please keep up, right? Don't let me get ahead of you. Use this podcast appropriately. So I've just gone ahead and I've drawn my y-axis. I'm going to go ahead, I'm going to label it also while I'm at it, right? Y. And I know now that my x-axis is going to be here, but I don't know what scale I'm going to need to put on it. Oops, I can't draw a straight line, but that's going to be my x-axis. We'll worry about the scale for a second. This idea here that I want to, this step 2, draw the sinusoidal axis and draw the maximum and min lines, that's a great idea just to kind of simplify what's going on with my graph. I'm going to go ahead and do that at y equals negative 8. I'm going to go ahead and draw a dashed line, and then I'm going to draw a dashed line up here at y equals 2 and at the bottom of y equals negative 18. Okay, so the reason why I'm drawing that is because the middle, the top, and the bottom, this is where all the interesting things happen on the graph, right? If I go and I think about a cycle of sine or of cosine, right? Here's a cycle of sine, right? There are points that if I know where this point and this point and this point and this point and this point are, and I connect the dots with a nice smooth curve, then I'm going to have a nice graph. These points are called critical points. And all of them happen on either the bottom line or the top line or the middle line. So that's why I'm going to think about drawing these dotted lines on my graph, because I know that all of the interesting points that I'm going to draw are going to fall on one of those 3 lines. Let's continue with the directions here. calculate the period, 360 divided by b, and the phase displacement, right, the value for theta that makes the argument equal 0. So the period, 360 over b, in this case b is 5, right? So the period is 360 over 5, which is 72. In this case, that's telling me that for this particular graph, it takes 72 degrees to complete a full cycle, right? Instead of 360 degrees, it takes 72 degrees to complete one full cycle of a sinusoid. In this case, the phase displacement, what do I need to plug in for theta in order to make this graph have an argument of 0? My phase displacement, I'm just going to call it phase because I'm lazy. That's pretty common. Sometimes phase displacement is talked about as phase shift, but I'm going to call it phase. I need to use a theta value of -6. That's saying that when theta equals -6, the argument for sine in this case is 0, and that's where the sinusoid starts, right? The kind of the first point, this first critical point is going to happen at theta equals -6. I need to figure out what scale I want to use on my horizontal axis. Now, I could just go up by ones, but with a period of 72, I would have to go up by ones for a long time, right? I could just randomly go up by tens, but then I would have weird values. You know, if I complete a cycle every 72 units, then my critical points are going to be estimating where they are. A nice thing to do is to choose a scale so that all of my critical points fall on tick marks, right? Like places on my grid. And a good way to do that is to look at if the period is 72 degrees, right? If it takes 72 degrees to complete a full cycle, the distance between critical points, right? There's 1, 2, 3, 4 sections of the graph in that 72 degrees. So if I do 72 divided by 4, which in this case 72 divided by 4 is 18, that's telling me that there are 18 degrees between critical points. So something interesting on my graph happens every 18 degrees. And I started my graph, right? That initial point was at -6. If I choose my scale to be something that goes in nicely to -6 and also into 18, that's going to give me all of the critical points are going to fall on grid marks. The biggest number that goes into -6 and 18 nicely is 6. And that's going to be the best choice that I'm going to use for labeling my axis horizontally. I'm going to go up by 6s. So here's 6, 12. After this, I'm only going to label every other one because I'm a little bit lazy. Oops, that's not right. So again, I'm going up by 6s, 6 in every square, but I'm only writing every other one. That's enough. And then -12, -24. Okay, so I've labeled my graph here with up by 6s. Okay, look at the next step. I've marked my scale. Mark the phase displacement on the graph. This point will be on the max, min, or sinusoidal axis, depending on whether the parent function or sine is cosine, sine or cosine. In this case, it's sine. So again, I'm going to look at this initial point in my my sinusoid here. Oh man. This initial point is what I'm trying to get at here, right? This one. When x equals 0 for a sine, or when theta equals 0 for a sine, I'm in the middle line, right, on the sinusoidal axis, and I'm on my way up. So that's saying that at a theta value of -6, which is right here, my graph is going to be in the middle on the way up. And I'm going to go ahead, I'm going to make fairly big marks for my critical points, especially this time, because I want you to see where they are. Okay, now 18 units later, remember we calculated that quarter period, 18 units later, I know that I'm going to have my next critical point, right? I'm going to be at the top of my graph. So 18 units later, -6 plus 18 is 12. Notice that -6 plus 18 is 12. It corresponds to 3 tick marks of the graph. 18 units is always going to be 3 tick marks of my graph. So my critical point after the one that's at 12 is going to be in the middle, right? Because I go up and then I go back down 3 tick marks later, which is right here. Now I can really get lazy about this, right? 3 tick marks, I'm going to be at the bottom, 3 tick marks back in the middle, 3 tick marks later at the top, 3 tick marks later in the middle, 3 tick marks later at the bottom. I'm actually going to go backwards from -6, right? If I was on my way up here, 3 tick marks before -6, I would have been at the bottom. And now I have all of my critical points for this graph labeled, and I'm going to try to connect the dots in one smooth curve. Now, this is something that I find particularly challenging to do with the stylus, but what my recommendation is try to avoid being really pointy like this. You don't want that, and you also don't want it to look like this, where it's like flat tops and flat bottoms. Shoot for something in between of those two, and it's good enough. Okay. That's not too bad. I also only like to draw one section at a time, kind of from the top to the bottom, and that way I tend to get a little bit of a better shape myself. Okay? It doesn't have to be perfect, but it does need to hit the critical points as much as possible. Okay, so there I have it. I've connected the points in one smooth curve. The last part of this podcast is going to address how do I go from, if I have the graph, how do I get the equation from it? But that is how you draw a sinusoid that has all the transformations. Oh, one last step. I'm going to label my x-axis because I'm lazy, or my theta axis. I did do that before. I just think it's important to label your axes. Try to remember to do that. Definitely put a scale on your axes. That is not negotiable. You have to have a scale on both of your axes, or your graph is no good. Okay.